Good morning.
Morning.
Okay, there are quite many people from our class already. Today is April the 10th, and I will read your names right now, so it will be a little bit faster than checking them in alphabetical order on the side, even though I see your names actually. So, Andrew?
Yeah.
Tima?
Hello.
Lorraine?
Here.
Lynn?
Here.
Juanita? Yuran?
Here.
Gabriel? Divina?
Here.
Kobe? Chantal?
Here.
Ricardo? Hochito? Gongsi? Kyle?
Here.
Matthew?
Here.
Julian?
Here.
Nathan? And Alejandro.
Here.
The first question which I like to address to everyone is about yesterday's test. Do we have anyone in our class who wants to go over certain problem? Let's say you tried certain problem and it was tough for you. Or if, let's say, you solved that, but you wanted to maybe have some additional feedback, or you just need to listen to maybe more detailed solution for any of these problems. I will be more than happy to answer your questions. Why I'm not going through entire thing, because according to the details on Wiley Plus, you had absolutely same kind of problems, but they were slightly different. You had different data, like, let's say different interest rate or principal value and etc. Again, in the nature, all these problems were absolutely the same, but you had different numbers. For each student, you had your individual set of values in all your problems. I will be more than happy to go over any problem if you request any of these problems. At the same time, if you used Wiley Plus, you immediately saw if the system accepted your answer or not. At the same time, I would like to say that in general, I don't think that these problems were difficult, and I'm not talking about this from my perspective, from my point of view. Maybe the most challenging problems, I think, were number 4 and number 5. Again, if you need any feedback, you are absolutely welcome to ask me, and I will go over all steps in that particular problems, or if you request some other problems to go over. Or you have another option. You can visit me virtually during office hours, and I will discuss particularly just your problem which you had through Wiley Plus. What should I do? The other option, I can start our trigonometric review. Please tell me what you are interested in. Guys, can you please reply to my question so I will know what to do right now?
I'm trying to remember which problems were which.
Excuse, I cannot hear. Can you please repeat?
I'm trying to remember which problems I needed.
Okay, so do you have anything in your mind?
I think it was number 4.
Number 4? Okay, okay. In this case, I will read number 4 or equivalent of number 4 as it is in your textbook. Let me grab that textbook. Just 1 second, please. I will find the location of that particular problem. Number 4 is on similar to absolutely similar to what you had. It's on page number 167. Just let me go to that page. 167. Just okay. It is section 4.4, and it was problem number 18. I'm going to read that problem loudly right now. If you like, you can even write it down. I'm talking problem itself, and I will go over solution. Are you ready?
Yeah.
A sum of $850 is invested for 10 years, and the interest is compounded quarterly. There is 1,000 in the account at the end of 10 years. What is the nominal annual rate? Okay, let's start discussing our problem. First thing, what you need to do, you need to define your variables, because this is a paragraph and we do not have variables assigned to this paragraph as unknowns. Is it okay if I will use capital B like a balance on that account?
Yeah.
So in this case, you need to write that let capital B be the balance for that account. T is numbers of years since the first day of that investment. So B is in dollars, balance in dollars, and T is time in years. So this is how we started the problem, because we need to be equipped by variables. And after that, let's start. T equals to 0. I think everyone understands that this is the amount which we usually call a premium. So this means that B at 0 is 850. At the same time, we know that balance will reach $1,000 after the end of the 10 years. So T equals to 10, then B 10 is $1,000. And we know that here it was the account compounded quarterly. What is the meaning of that? It means that n equals to 4. N here represent the number of compoundings per year. In 1 year, we have 12 months. Quarterly means it is done 4 times during 1 year. And if we divide 12 months by 4, it is at the end of each 3 months cycle, interest is compounded and added to your account. Excellent. Right now, I am going to write the formula for that situation. This formula you can find on page 100, page 167 in the box. It states that balance equal to the principal times parenthesis 1 plus r divided by n to the n times t. This is the formula which you have on page 167. And we have values right now for p, it is b at 0. We have a value for b, which will be used like b when t is equal to 10. We now know that n is equal to 4. The only unknown here is r. So let's plug all this information here. So it will be 1,000 equals 850, 1 plus r over 4 to the 4 times t. 1,000 equals to 850 times parenthesis 1 plus r over 4 to the 4t as a power. And we now need to solve this equation with respect to r, because in this equation we have only one unknown, and it is the rate. And this is actually as our nominal rate. So let's do that. Can we divide both sides by 850?
Yes.
So let's do that. 850 will disappear on the right side. We can divide both numbers here by 10. Can you see I crossed zeros? But at the same time, 100 over 85 is also reducible because both numbers can be easily divided by 5. So let's
T be 10?
Numbers. Excuse me?
Shouldn't T be 10?
I first reduce them by 10. Instead of 1,000, I'm dealing with 100. And instead of 850, 85. But you can, let's say, divide by not doing what I did, crossing out that zeros at the end of these numbers. You can divide, let's say, 1,000 by, let's say, 50 instead of 100 divided by 5. Up to you, you will get the same result. 100 divided by 5 is 20. 85 divided by 5 is 17. So you are getting the following equation. 20 over 17 equals parenthesis 1 plus r over 4 to the 4t. 20 over 17 equals to 1 plus r over 4 to the 4t. But what about that t? Can I replace this by 10? Guys.
Yeah.
So 20 over 17 equals 1 plus r over 4 to the 40. To the 40. And r is our unknown, and it is inside of that parenthesis. This is algebraically can be called like polynomial equation of the 40th degree, but it is Thanks God, it is for our benefits that it is so-called incomplete polynomial equation of the 40th degree. We have here quite many different ways to solve. If you like, you can even use logs to both sides, but using logs to both sides will make the process a little bit longer. There is much easier way to solve this type of equations because our unknown is locked inside of the base. It is inside of parentheses. If I were you, because it is actually, again, an incomplete polynomial equation of 40th degree, I will raise both sides of that equation to the power, which is here reciprocal to 40. Reciprocal for 40 is 1 over 40. This why I am surrounding this last line again by parentheses. This is much easier way to solve this equation than logging both sides. Look what I did. I raised both sides to the power which is reciprocal to what we had. We had 40. So, and I'm going to use simple algebraic formulas. Do we know that when we raise power to the power, we need we need to keep the base and multiply exponents?
Yes.
This why on the right side, if we multiply 40 by 1 over 40, result will be 1. So we are getting 20 over 17 to the 1/40th power equals 1 plus r over 4. R over 4. So far, so good?
Yeah.
Can I continue?
Yes.
Okay. I need to solve it for r. So this one on the right side bothers my eyes. So what I'm going to do, I will remove it from there. You have two options. You can subtract one or move this to the left, changing its sign. I am going to move it. So it will be 20 over 17 to the 1 over 40 minus 1 equals r over 4. R over 4. And I really like to remove that 1/4 from the scene. What can I do? I can multiply both sides by 4. So I'm multiplying one side by 4, and because the other side has not only one term, I'm surrounding by brackets or parentheses. This is what I did, you can see, and here brackets or parentheses on the left are mandatory. Simply canceling both fourths on the right side, I am getting an expression for r. R exactly equals to 4 times brackets, parentheses, 20 over 17 to the 1/40th, 1 over 40 as a power, minus 1. This is the exact value for r. And now you need to use your calculator to estimate that value for r. Please be careful when you enter this into calculators. Let's start. Turn your calculator on and follow exactly the sequence of these parentheses as you have in your calculator, on your paper, excuse me. So it will be 4 times parentheses, and you need to open right away another set of parentheses to include 20 over 17. 20 divided by 17, close parentheses, to the, so far I'm showing you just part of what I entered. I will continue. Now I need to enter that exponent, 1 over 40. I am opening parenthesis again. 1 divided by 40, close parenthesis. What you have after, minus 1, close parenthesis. And push enter. Please do that. And I will release what I have on my screen also, but try to do that right now independently and tell me about your result. Again, please be careful with all these parentheses, because if you accidentally miss some, do you need my help? I can show this on my calculator. I have a value already. Would you like to see what I have on my calculator?
Yeah,
Yes,
I think I answered it wrong.
Please look at the old sequence of parentheses. Can you see that numbers on your
Yeah.
screen? So 4, you can push times, or you can just simply open parentheses. Again, parentheses around 20 over 17 to the parentheses around 1 divided by 40, close parentheses, and close parentheses after minus 1. So practically your R is approximately 0.016, and this is a decimal version. If we like to convert this into percentage, so it will be 1.6%. So your nominal rate is 1.6%. Did you have an opportunity to write everything down?
Yes.
Yeah.
Excellent. Do you have a request for any other problem?
I think we're good.
No, thank you. There's
Okay.
no other ones.
Can I start trigonometry?
Yes, please.
Yes.
Okay. But again, if you need any additional help, please do not hesitate to visit me during office hours, because I'm all the time available through Zoom during office hours, and I will try to answer all your questions. Okay. Last time we tried to talk about trigonometry. Unfortunately, I discovered that quite many people do not remember many important things. And again, I'm very serious about that. Please use that coming weekend to do quite serious review of trigonometry. I'm going to remind you right now some information from beginning of trigonometry. We will be mainly talking about so-called trigonometric circles. But before we start talking about trigonometric circles, I would like to say something in general about a circle. A circle is a geometric mathematical figure, special type of figure. How can we describe the figure? A circle is a set of points equidistant from one fixed point, because on this circle, each point is located on the same exactly distance from one point, which we call as the center of that circle. Set of all equidistant points from one fixed point. This is the geometric definition of the circle, but it has an algebraic equation right here on the piece of paper, because I already prepared that in advance. You can see an algebraic equation of a circle which has its center at the point with coordinates A and B, and radius r. It is right there at the top of the paper. X minus a parenthesis squared plus y minus b squared equals to r squared. And you can see here words. It is a circle with a comma b point as a center and a radius r. But what about so-called trigonometric circles? Trigonometric circles are special type of circles where center is at the origin. So which means it is a point with coordinates 0, 0. And in this case, point A comma B is a point parenthesis 0 comma 0, which means A is 0 and B is 0. If you plug A equal to 0 and B equal to 0 into your equation of the circle, general equation of the circle, you can see what you get. It is in the box on the second line. Can you see that? It will be x squared plus y squared equals to r squared. This is an equation of any trigonometric circle. X squared plus y squared equal to r squared. At the same time, you probably remember that quite many times, very often, instead of just a trigonometric circle with any radius, we actively used so-called a unit trigonometric circle. What is the difference between trigonometric circles and unit trigonometric circles? Difference is only in r, radius. It also should have its center at the origin because it is a trigonometric circle, but r should be equal to the 1 unit. And you can see that equation on the third line. You can see point A comma B is again 0, 0 point. R is equal to 1. Then we see another box. In this box, we see that new equation, x squared plus y squared equals to 1. Why it is 1? Because 1 squared is 1. So basically, it is same equation as you see in the first box, only when r is equal to 1. This is the only difference. Can I continue?
Yes.
And look what I did. I have right now 2 circles side by side, and here I'm showing angles theta in both circles. One circle, it has its equation right here. It is so-called trigonometric circle. Another one has equation right here. It is x squared plus y squared equal to 1. So radius is equal to 1. But it has same theta in both circles. I'm talking about same congruent angles, measured in degrees or radians, doesn't matter. And this why you can see 2 slightly different definitions of trigonometric functions in both circles. If you look at the first column, you can see sine theta equal to y coordinate over radius. Cosine equals to x coordinate over a radius. Tangent equals to the ratio of y coordinate to x coordinate. Cotangent is a ratio of x coordinate to y coordinate. Secant theta is ratio of radius to x coordinate. Cosecant is a ratio of radius over y coordinate. If you precisely look at each of these definitions, you can see pairs of reciprocals. Pairs of reciprocals, like first from the top and first from the bottom. These functions are reciprocals. Can you see I connected them with arrows? These two guys, first from the top, first from the end, there are reciprocals. Now, if you compare second from the top and second from the bottom, they are also reciprocals. Also reciprocals. And two guys in the middle, which are third from the top and third from the bottom, they are also reciprocals. We have here three pairs of reciprocals as functions: sine theta with cosecant theta, cosine theta with secant theta, tangent theta with cotangent theta. Now we can move to here. We have on the same page, we have definitions for unit trigonometric circle. Why do we use unit trigonometric circles? Because definitions look slightly easier, very slightly, but anyway, easier. Because if in this circle with radius r not equal to 1, definition for the sine theta was a ratio of y coordinate to the radius, but here it is just y coordinate of the endpoint. Cosine is equal to x coordinate, but tangent and cotangent, if you compare two approaches, they look identical. Definitely I'm using different coordinates, like I use here C comma D for the first point, and here I'm using M and N, but the nature of coordinates is the same. For both cases, tangent is equal to the ratio of y coordinate over x coordinate. Cotangent is the ratio of x coordinate to y coordinate. So which means this is a full match. But secant theta equals to 1 over m, because it is radius equal to 1 over x coordinate, which is m, and cosecant is also 1, again, because radius is equal to 1 over n, which is your y coordinate. And here again, we have same actually pairs of reciprocals, 3 pairs of reciprocals. And I again show right now these 3 pairs. But we have tons of formulas, and we are going to go briefly over that formulas. Please tell me if it is quite very detailed review. I can skip many actually details, or should I continue in the same way?
Continue.
Okay.
Yeah.
Now I'm going to write formulas right here in the middle. And let's say that we are using actually a point. Now I'm going to, instead of using in one case C and D, in other case it's a M and N, I'm going to use a point which is X comma Y. And let's say in general radius is R. So if it is a unit trigonometric circle, just simply replace that R by 1 and you will get everything for unit trigonometric circle. Again, so what about this XY? XY is a, I will show you small, ugly, maybe circle. I really apologize. I don't have right now time to sketch really good looking circle. So, oops. And let's say this is angle gamma. Just 1 second, let me show where we have X, Y, and where we have sides of this. This is R. This is Greek's letter gamma. So you can see that this point, XY point, is the end point on so-called terminal side, because this angle gamma has two sides, so-called initial side, that one which is close to that letter R, it is an initial side. It coincides with the positive direction of x-axis. The other one is so-called terminal side. Initial side is not moving. It is attached to that position. It is right there on the positive side of x-axis. But terminal side is movable. Each time when we move it around the center, we are getting more and more angles. From that point, which is right here, it is 0 degrees angle or 0 radians angle. We can move up or down. If we are moving up, we are moving counterclockwise. It is for positive angles. When we move down, we are creating so-called negative angles. This is what I'm showing direction. For example, right now, I have angle gamma on this circle, which belongs to the third quadrant, because we have quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4, because X and Y axis, they divide this plane into 4 quadrants. Quadrant number 1, quadrant number 2, number 3, and number 4. Gamma, according to what we see in the circle, belongs to the third quadrant. What is the meaning of that? It means both coordinates X and Y are negative. What is very important for first quadrant? Both coordinates are positive. It is like in opposition for quadrant number 3. In first quadrant and the third quadrant, both coordinates carry same signs. In first, they are both positive. In the third, they are both negative. In the second quadrant, X coordinate is negative, Y is positive. In the fourth quadrant, X coordinate is positive, but Y is negative. And it is really important because I can write it down right here. Plus, comma, plus, minus, comma, plus, you will see that right now here. Plus, comma, minus, I'm just showing the coordinates inside of each quadrant. You will see that right now in this circle. Top, both coordinates positive. In the second and the fourth coordinates have opposite signs. In the third, they are both negative. This is what we see. Because it is really important, this information will help us to indicate what kind of signs, positive or negative, all 6 trigonometric functions have in each of these quadrants. And now, if you look precisely at this definition, specifically at the definition of the trigonometric functions in the unit trigonometric circle, you probably can see that we easily can write the following formulas. Y coordinate equals R times sine theta. X coordinate equals R times cosine theta. First formulas. So if you know an angle and you know the radius, you can easily find coordinates of the endpoint of the terminal side, definitely. These formulas have practical usage and you can solve many problems. Next, formulas. And now I'm going to list formulas which we can use for any kind of trigonometric circle and not actually for circle. These formulas work for angles from the triangles. So sine squared theta plus cosine squared theta equals to 1. I usually all the time prove all these formulas if I teach trigonometry course, but you already had this proof. This is why I'm not doing that. Now I'm trying to use that property of reciprocals because you can write this in many different ways. Just 1 second, let me show what I wrote down. Look what I wrote down. Sine theta I wrote times cosecant theta equals to 1. This why, if you like to solve it for sine theta, you need to divide both sides by cosecant theta. So basically, this form has 2 other formulas inside, like sine theta equals to 1 over cosecant theta, or cosecant theta equal to 1 over sine theta. And same thing I can write for 2 other pairs. For example, cosine theta times secant theta this time equals to 1. And this is one formula from which you can get additionally 2 others. Again, like cosine theta equal to 1 over secant, or secant equal to 1 over cosine theta. And for tangent and cotangent, this is like so-called basic formulas. Just listing these formulas to remind you. Another important formula is formula for tangent. Another one is code for cotangent. What do I mean? Tangent theta is equal to the ratio of sine theta and cosine theta. Cotangent theta is the ratio of cosine theta over sine theta. So far right now, I am listing the basic trigonometric formulas which you learned at the beginning of this course. Guys, do you need these formulas?
Yes.
Do you have an opportunity to write them down in quite fast way? Can I continue with more formulas?
Yes.
Yes.
So far, these are formulas which are coming in practically first chapters when you start analytical trigonometry. Another formula, tangent squared theta plus 1 equals secant squared theta or 1 over cosine squared. More often it comes just with secant squared, tangent squared plus 1, or it can be like 1 plus tangent squared theta in the switched form, doesn't matter. So it is equal to secant squared theta or 1 over cosine squared theta. Okay, similar to that, cotangent squared theta plus 1 equals cosecant squared theta or 1 over sine squared theta. And I will show right now a problem applying these formulas. First, you definitely need to review values of all trigonometric functions for specific angles. What kind of angles? For all quadrantal angles are 0 degrees or 0 radians, 90 degrees or pi over 2, 180 degrees or pi, 270 degrees or 3 pi over 2, 360 degrees or 2 pi. So again, I wrote them all down. These are so-called quadrantal angles. I'm listing them right here. Please, you need to know all these values. Besides that, you need to know values for so-called reference angles, which we use a lot in trigonometry, like 30 degrees, or it is in radians pi over 6, 45 degrees, or in radians pi over 4. And please again use this coming weekend to restore all this information. I will not have time to go over that because I'm not actually obligated to do that. This material is not based. This is your assignment. So this I listed right here. I listed all these angles, and you need to know values of all 6 trigonometric functions for these particular angles. And let's say now we have a problem in which we have the value of cosine. Let's say cosine theta is equal to 1/5, and theta belongs to the 4th quadrant. Cosine theta equal to 1/5, theta belongs to the 4th quadrant. And I need to find values of all 5 remaining functions. What should I do? First thing, I recall that information about reciprocals. Which function is the reciprocal to cosine theta? Secants. So secant theta is equal to 5. Because it is a reciprocal of cosine. Now, I already have 4 unknown functions values. So what is the next? I think it is easy to right now find the value of sine theta. Please don't forget to write down theta, because sine squared without theta does not have any meaning. I am using that formula, sine squared plus cosine squared theta equal to 1. So it will be sine squared 1/5 squared equals to 1. And I'm going to solve this right now to find sine value. So sine squared theta equals 1 minus 1/5 squared. It is 1/25. Sine squared equals to 24/25. And to find the sine value, I need to take square root from both sides. I need to take square root from both sides. But if I take square root from both sides, I need to consider probably plus and minus, or plus or minus signs. This why location of this theta will help me to choose. Theta was from the 4th quadrant. And I know that sine as a function is affiliated with y coordinate. In the 4th quadrant, y coordinate is positive or negative?
Negative.
Negative.
That's it. So which means sine of theta should be negative. So sine theta equals minus Square root of 25 on the bottom is just 5. 24. Is it perfect square? No, it is not. But what kind of combination can help us? Is it 4 times 6?
Yes.
Square root of 4, is it 2?
Yes.
So, and I have the value for that. So I am boxing that value. This is the value of sine theta, negative 2 square root of 6 over 5. If I know now the value of sine theta, I can easily find the value of its reciprocal. So cosecant theta is the reciprocal of that. So which means it will be definitely negative, and just reciprocal of that is negative 5 over 2 square root of 6. But we usually do not leave irrational numbers on the bottom of the fraction. So what I'm going to do, I will multiply top and the bottom by square root of 6. So what I'm getting here, negative 5 square root of 6 over square root of 6 times square root of 6 is the square root of 6 squared, times 2, it is 12. And I have another value which I found already. I'm left right now can you see, guys?
Yes.
Yep.
Did you write it down?
Yes.
I'm left with 2 unknowns, tangent and cotangent. Let's find them. If I know sine value, cosine value, it is piece of cake. Tangent theta, sine theta over cosine theta. I'm writing this down and I'm plugging their numbers. Here on the top, I have negative 2 square root of 6 over 5. Cosine is 1/5. So if you convert, if you convert this into multiplication by the reciprocal, 5 will be canceled. So which means right now we can easily, excuse me, it reminds me about the end of our class. So 5 and 5 are gone. Negative 2 square root of 6, which is the tangent's value. I am finishing right now. Negative 2 square root of 6, and cotangent is the reciprocal of tangent. So it will be negative 1 over 2 square root of 6, and I'm going to remove irrationality in the same manner as I did before. So it will be negative square root of 6 over square root of 6 squared is 6 over 12. And I am completely done with the problem. I found all missing values. I used formulas and I used information about what kind of positive or negative signs functions have in the 4th quadrant. You solved many of these type of problems in your trigonometry course. On Monday, I will actively solving problems, proving identities, operating with different formulas. And it is just small portion of formulas because again, we have formulas for double angles, half angles. We need to talk about inverse trigonometric functions, graphs of these functions. There is a lots of material, so many different topics which we need to go through. If I already called your name, checking attendance, you can leave, but I still have some names which I need to call again. So,
Professor,
excuse me?
is there any way you could post these notes and send it to us so we can review it?
I will be actually sending you the video link.
Oh yeah, okay.
So, and this why you will definitely can have opportunity to, but this is again, you can have an opportunity to go over that again, but please be serious, because again, it is just small portion of formulas, and I will be definitely just mentioning some other formulas and working with that formulas, but you need to do a lot of your own research as well. Definitely you will see the copy of a video of a copy of that lecture. It will be, I will send a link to that to you. So I'm going to call some names right now. Juanita. Who is next here? Gabriel.
Here.
Gabriel, I need to talk to you. Can you please stay after other? I will tell you when other are leaving. I have some question.
Okay.
Okay. Kobe. Ricardo. Hochtel. Gongsi.
Here.
Nathan. Okay. I would like to ask short question, Gabriel. You can stay. All others, have a nice, beautiful weekend. Okay. So. Okay, Gabriel, I see just your only name right now on the side. So we are just now face to face alone.
Okay.
Why do you participate systematically all these lectures much later than all other students?
It's because like when I start to search the email of Zoom meeting, I take like 5 minutes to find, and then I start the class like 12:15 usually.
Okay. Another question is, if you know that you are facing this problem, why you do not start earlier?
Because I have another class before, and then it takes like some time.
But we have at least 10 minutes before classes. Another class, do they do that also at the fixed schedule as you had in the class in our college?
Yeah, but it starts like 5 minutes late, the other one.
You mean the other class starts 5 minutes late?
Yeah, and it ends like sometimes at 12:05, 12:07.
Because I don't know if you mentioned that or not, but I all the time start my class sharply at the time, or even I can be available a little bit earlier. So, okay, try to resolve, because I'm starting actually checking attendance and talking about material right from the beginning. Okay?
Okay.
Okay. So have a nice, beautiful weekend. Please review formulas, okay?
Thank you. You too.
Bye.
Bye.